Hi, welcome to Dissolve Chemistry. Let us continue our discussion on this thermodynamics. In the previous video, we started our discussion on Gibbs free energy change, and we have discussed the definition of Gibbs free energy change. Then what is standard Gibbs free energy change, we have discussed physical significance of that, okay, and how we are going to relate that with the spontaneity that we are going to discuss in detail in this particular video. Prior to going for that, we will see certain conditions under which how our Gibbs free energy is. So that in that first is the standard Gibbs free energy of formation, we will see. So standard Gibbs free energy change for a during formation is what? The change in Gibbs free energy when 1 mole of the compound is formed by the combination of constituent elements. So that we call it as what? Standard Gibbs energy change of a formation we call. Then next is standard Gibbs free energy of the reaction. Okay, so how we are going to define? It is the difference in the standard Gibbs free energy of the product minus standard Gibbs free energy of the reactants. Okay, so we will show like this mathematically. Delta R of G naught of product minus delta R, just we can write like delta G R. Okay, so that is how we are going to represent overall Gibbs free energy of the reactants, overall Gibbs free energy of the products. The difference we are going to call it as what? Gibbs free energy, standard Gibbs free energy change for a given reaction. Okay, the next topic we are going to discuss is that is crossover temperature. What do you mean by this crossover temperature? Okay, so now for example you consider what we have said, when the Gibbs free energy change for a given reaction, if it is negative and its magnitude with negative sign, if it increases, so then the process is said to be more spontaneous, we called, right? We called it as spontaneous, and it depends upon what? The value of delta H and value of delta S. Okay, now when you fix these two conditions, that is change in enthalpy and change in entropy, if we fix, then the change in Gibbs free energy is dependent upon what? Your temperature. Okay, so now as you consider the temperature, okay, suppose for example now your reaction is at equilibrium, then your delta G will be 0. So therefore then what happens? Right? Delta H is equal to T delta S we will get. Okay, when delta G is equal to 0. So now means it is condition of equilibrium we call. Okay, it is a condition of equilibrium. Now here what happens? T is equal to delta H by delta S. Okay, the ratio of change in enthalpy with change in entropy is called as what? Crossover temperature. And always remember, at this crossover temperature, your change in Gibbs free energy will be 0 and your reaction or process will be at equilibrium. Okay, and if you move beyond this on either side, one side will be spontaneous, another side will be non-spontaneous. Okay, and that particular temperature at which delta G is 0, so there your what? The process is at equilibrium you have to consider. So that we will make it as a graph that you can understand. Okay, so we'll make out like this. When the reaction depends upon the temperature, okay, when the values of delta H and delta S are fixed, and if it is going to depend upon the temperature, then what happens? This your crossover temperature, where T is equal to delta H by delta S. Okay, is equal to 1 if it comes, or it is having certain value whatever it is. So there your delta G will be equals to 0. Okay, and beyond this one side it will be spontaneous, maybe spontaneous or non-spontaneous. We don't know that one, that we will see conditions. Okay, very soon we are going to see that one, right? Or on this side what it should be, either it is spontaneous or non-spontaneous. Okay, so now at this point what you are going to see is that your delta G is equal to 0. So therefore it is, we can call it as what? It is at equilibrium, that at that particular temperature. When the values of delta H and delta S are fixed, then our Gibbs free energy depends upon the temperature and exactly the middle temperature. Okay, so that we call it as what? Crossover temperature. Please make note of these things. Okay, let us move on to the next topic. In most of the reactions, we are going to write on the arrow mark while writing the reaction that a particular fixed temperature we are going to mention, like 500 degrees Celsius, 600 degrees Celsius, 100 degrees Celsius. Or we are going to check that one from the beginning, that 0 degrees Celsius, let us check the reaction either going to occur or not. Or after that, next 1 degree by rising, every degree rise, and we are doing the experiment. It's not like that. So we are going to get that one from this Gibbs free energy change. And let us relate that one. Okay, there are many processes which are at low temperature. If they are non-spontaneous, if you take to the higher temperature, they will become spontaneous. Okay, and some of the processes are as such that they are spontaneous at either temperature, or they are independent, their spontaneity is independent of the temperature we are going to see. Okay, so like that, different conditions we will take, as such we can understand the concept of spontaneity with respect to the Gibbs free energy change, because this is very important in deciding the conditions or reaction conditions. Okay, so that we will see. So for that we will take 4 situations, right? So all those 4 situations, what happens to your Gibbs free energy at 2 different temperatures we will consider. Okay, so let us look into the relation between Gibbs free energy and spontaneity. Okay, so we will take, say for example, case 1 we will take. In that, 2 things we are going to do. So where what we will do, we will take a system, right? So system, what it does is, let us take it as it is absorbing 500 joules of energy. The system, if it absorbs energy, meaning is what? From the surrounding, means it is endothermic process. What we are considering? Endothermic process. Okay, and under 2 temperature conditions, one we will take it as what? 600 Kelvin, and another temperature we will take it as 200 Kelvin. Same system. We will assume it that this much amount of energy is absorbed under 2 conditions, at 200 degrees Celsius and at 200 Kelvin and 600 Kelvin. And let us fix that your delta S is equal to 2 joule per Kelvin. We will take 2 joule per Kelvin. Means what it is doing, your change in entropy is positive, meaning is what? Your system is going to expand by the absorption of this energy. And with what energy it is expanding? 2 joules per Kelvin. Okay, so now we will see at 2 different temperature conditions what would be our delta G. Okay, so we know that delta G is equal to delta H minus T delta S. So this is our delta H Okay, system when it is absorbing, or if the change in entropy is 2 joules per Kelvin, meaning is what? By absorption of this 500 joules of energy at 200 Kelvin, it is going to expand, or it will utilize that energy to expand itself. Or we can consider it as at 600 degrees Celsius with 2 joule per Kelvin, our system is going to expand. Condition what we have taken? Endothermic process, and first we are considering expansion. And how we can identify that one? Whenever change in entropy, if it is positive, so then we call it as what? It is doing expansion, or system is expanding by absorption of the energy. So now let us calculate. First we will calculate at 200 Kelvin. So therefore delta G is equal to, already we know delta H is 500 joules minus T is how much? 200 Kelvin. Okay, and your delta S is, so that is 2 joule per Kelvin. Okay, Kelvin per Kelvin get cancels. So then what it remains? Into 2 means it becomes 400. Okay, minus, and it is 500 joules. Okay, it turns out to be how much? Delta G is equal to 100 joules we will get. What is the meaning of this? The sign is positive. Okay, now we will come to that conclusion later. So we will see this one. Next is, so we will take it at temperature is at temperature 600 Kelvin. What it is going to happen, that we will see. Okay, so now at 600 Kelvin, your delta G is equal to what you will be having? 500 joules of energy is being absorbed by the system. Okay, at 600 Kelvin, and your entropy is 2. So now what happens? It becomes total 1200, okay, joules, and here it is 500 joules. Overall it turns out to be how much? 7 minus 700 joules. So therefore your delta G is how much? Minus 700 joules. Means the same process, if you are carrying out at 200 Kelvin, then your system is what? It is non-spontaneous. The process is non-spontaneous because your delta G value is positive. Delta G value positive meaning is what? The process is said to be non-spontaneous when the temperature is 200 Kelvin. So therefore spontaneous, okay, at 700, or we call it as what? At 600 Kelvin. Okay, then which is the middle temperature? Means where your entropy of your Gibbs free energy change is 0. So that we can calculate by crossover temperature. T is equal to delta H by delta S. So therefore delta H is 500 joules and your delta S is how much? 2 joules per Kelvin. So therefore joules get cancels per Kelvin. If you take on to the top, it will becomes Kelvin. So therefore it is around 250 Kelvin. At 250 Kelvin, your delta G will be having 0 value. You should remember that. Okay. So therefore how we can make out the scale? So therefore at 250 Kelvin, okay, delta G is equal to 0 and your process is at equilibrium. Okay, and if you go beyond this temperature, okay, plus if you go, okay, then your process is said to be spontaneous, and below this temperature your process will be non-spontaneous. Okay, below this non-spontaneous, we will show like this. Above this spontaneous, and at this point it is Gibbs free energy change will be 0, and that temperature we call it as what? Crossover temperature. I think you have understood this one. Okay, we will take that one. Means what is the meaning of this? Means when the process is endothermic, okay, and if it undergoes expansion, means change in entropy is positive, okay, and enthalpy is also positive. In that case, okay, it depends upon what? Temperature. Okay, at higher temperature it is spontaneous, at lower temperature it is non-spontaneous. Okay, we will move on to the next condition. What we will do is we will keep it as endothermic process, meaning is delta H is equal to positive and your delta S, now what we will do is equal to negative we will take. Okay, now endothermic, instead of expansion we are doing compression, means your system is undergoing compression, means it is compressing one side and it is absorbing heat from other side. Then what happens we will see to the Gibbs free energy change. Okay, this is your system, it is undergoing compression with what? Getting ordered, you can say, by delta S is equal to same value we will take, but sign we will take it as minus 2 joule per Kelvin. Now same 500 joules we will give energy. It is again plus endothermic, delta H is equal to. Then let us see at condition number 1 is 600 Kelvin and another condition is 200 Kelvin. Okay, let us calculate at 200 Kelvin and at 600 Kelvin. Now your system is contracting. Okay, it is contracting instead of expanding. That is indicated by delta S sign with negative sign. Fine. At 200 Kelvin, delta G is equal to what is that? Delta H is 500 joules minus T is how much? 200 Kelvin. Okay, into your minus 2 joule per Kelvin. Per Kelvin, Kelvin get cancels, minus 2 joules into 200, what it turns out to be, minus into minus plus. So therefore it becomes 400 joules and it is 500 joules. So overall it turns out to be plus 900 joules. Okay, delta G is equal to. Similarly, we see at what? Temperature 600 Kelvin. Okay. So now at 600 Kelvin, it is going to be delta G is equal to, so here we will write 200 into minus 2. Okay. So here it is 500 joules minus T is 600 Kelvin into minus 2. So now it turns out to be how much? 1200 minus into minus it becomes plus. So therefore plus 500 joules plus 1200 joules. Overall it turns out to be plus 700 joules, your delta G. So you can see that irrespective of the temperature, when the process occurs with absorption of the heat and contraction if it is taking place, instead of expanding or increase in entropy, decrease in entropy if it occurs. So then what happens? Irrespective of the temperature, your process will be non-spontaneous. Here it is also non-spontaneous. Okay. And here it is also non-spontaneous. So when it is non-spontaneous, do you have crossover temperature for this? Yes. So you cannot have the crossover temperature because irrespective of the temperature, it is what? Non-spontaneous. Therefore, in this condition, no crossover temperature. What is the reason for that? Because at all temperature, our process is non-spontaneous. Hence, no crossover temperature for this. Is it clear? Meaning is, you should remember the conditions. When delta H is positive and delta S is negative, irrespective of the temperature, the process will be always non-spontaneous. Okay. Exothermic and expansion we will take. Expanding means delta S is positive and delta H is negative, meaning is what? Exothermic. So now we will see the same temperature conditions we will take. Okay, our system is working at 600 Kelvin and 200 Kelvin, and our delta S is plus 2 joule per Kelvin, and amount of heat energy absorbed instead of absorption. Now what happens? Heat is given out by the system, that we will take it as delta H is equal to minus 2. Heat is given out or comes out. Heat is given out, along with that our system is expanding. Okay, and it is undergoing more disordered, or randomness is increasing with 2 joule per Kelvin. Okay, so then what happens at two different conditions we will see. At 200 Kelvin, okay, let us substitute the values. So delta H is minus 500 joules minus, okay, 200 into 2. Okay, so that turns out to be how much? 400 plus minus 500 joules minus 400 joules. So it turns out to be minus 900 joules. Delta G is equal to, meaning is what? The process is spontaneous, because delta G value is negative. Similarly, we will see at 600 Kelvin. So you see here delta G is equal to minus 500 joules minus 600 into 2. So that turns out to be how much? Minus 1700 joules. Okay, delta G is equal to. So therefore here it is also once again spontaneous. So that is why any process, if it is exothermic, irrespective of the temperature, it is going to be what? Yes, if the entropy is positive and enthalpy is negative, then irrespective of the temperature, what happens? The process will be always spontaneous. And let me know, do we calculate or check the crossover temperature here? It's not possible to get the crossover temperature, because at any temperature, either it is high or low, if the process is exothermic and which is happening with the expansion, means increase in entropy, okay, then what happens? It will be always spontaneous. Okay, so next is last one we will see. So that exothermic, instead of expansion, if it is undergoing compression or contraction, so then what happens? We will see that the entropy is now negative. Okay, when both are negative, then what happens? Contraction we call. Now instead of expansion, the system is undergoing, it is evolving heat energy 500 joules. Along with that, what it is doing? It is undergoing contraction by how much? By minus 2 joule per Kelvin. Okay, now we will see at two different conditions of temperature. At 200 Kelvin, delta G is equal to, what happens? See, you substitute minus 500 minus 200 into minus 2. So now what it turns out to be? Minus into minus plus 400 minus 500. So therefore it turns out to be minus 100 joules. So therefore at lower temperature your process will be spontaneous, even it undergoes what? Contraction instead of expansion, that is change in entropy is negative. Similarly we will see at 600 Kelvin. Okay, so now what happens? At 600 Kelvin, delta G is equal to minus 500 minus 600 into minus 2. So now it turns out to be how much? So minus into minus plus 1200, okay, and minus 500. So now it will be plus 700 Kelvin. Okay, delta G is equal to plus 700 Kelvin. It means what? At higher temperature, okay, even though it is exothermic, If it occurs by contraction or decrease in entropy, then the process is said to be what? Yes, said to be non-spontaneous. Okay, it is said to be non-spontaneous. Again, what we will be having, the crossover temperature, we will see that one. Okay, so crossover temperature, how we can calculate? T is equal to delta H by delta S. Okay, so what is your delta H? Minus 500. And what is your delta S? Minus 200. Minus minus get cancels. Okay, sorry, minus 2. So it turns out to be how much? 250 Kelvin. Okay, so beyond this 250 Kelvin, okay, this side, okay, less than 250 Kelvin, if it is there, then it is spontaneous. Okay, and above this 250 Kelvin temperature, it will be non-spontaneous. Okay, and at this temperature, it will be, your delta G will be is equal to 0. Here your delta G is equal to negative, and here your delta G is equal to positive. Okay, and it is at equilibrium. Okay, so you should remember this. I hope you have understood all these four conditions what we have taken. Okay, let us summarize that one. Okay, and we will conclude here. I think you have understood what is crossover temperature means. Okay, so let us move on to that. Let us check the spontaneity. So we will draw the conclusion of this, right? So we will have condition of change in enthalpy delta. Summarize this. When delta H is positive, meaning is what? Endothermic. Okay, and delta S is also positive. Okay, means expansion. Your system is expanding by absorbing the energy. Then delta G will be always positive. Sorry, delta G will be negative at higher temperature, right? And delta G will be, when it is positive at lower temperature. Okay, so your means at higher temperature it will be spontaneous, and at lower temperature it will be non-spontaneous. Okay, then next, if delta G is positive, and if it is negative, okay, so then what happens? So if this is negative and this is positive, it will be positive. Okay, always at both higher and lower temperature, or it is independent of the temperature. It will be always non-spontaneous. Okay, then next, first condition, second condition, third one is, okay, we will see this when enthalpy is negative and entropy is positive, okay, then it will be always negative. Always we write always negative, which delta G. So at both high as well as low temperature, or it is independent of the temperature, we can say low temperature. So therefore always it is spontaneous. Means energy is given out. Along with that, what happens? Your change in entropy, or the system is undergoing expansion. Here you write exothermic expansion. Here you should write contraction. Okay, now we will take it is also negative, means contraction. Heat is given out, along with that it is undergoing what? Contraction. Okay, means entropy is decreasing or it is negative. So then what happens? It will be, okay, negative at low temperature. Meaning is what? Spontaneous at low temperature, and positive, okay, at high temperature. Means it depends upon the temperature. You should remember temperature. So therefore it is non-spontaneous. Okay. So if both are negative, then delta G will be negative at low temperature and it will be spontaneous. And if delta G is positive at high temperature, okay, so then it is non-spontaneous. Okay, I hope you have understood the meaning and all this what we have given. Please make note of this, is very important. So in this we have discussed the relationship between Gibbs free energy and the spontaneity of the process. Along with that, we have understood what do mean by this crossover temperature. Okay, so thank you for watching and please subscribe our channel.